Welcome back to Math 103. This is video number 29 on growth and finance. If you can repay $3,000 1 year from now, and the annual interest rate is 9% compounded annually, how large a loan can you afford to take out now? It's very important in our classification of problem types that this is the first kind of problem we looked at in the chapter. This is a one-time transaction. You get a certain amount of money in your hands now in the form of a loan, and you pay it back all in one shot a year from now. That's a one-time transaction, not a succession of transactions. So we are not yet talking about an annuity. So instead, it's a job for the compound interest formula. Future value equals present value times 1 plus I to the number of compounding periods. This n means something a little bit different in the compound interest formula than it does in the annuity formula that we've seen. So $3,000, this known quantity, is the target amount that PV will grow into. 1.09 is 1 plus I because there is no more frequent compounding. This is just annual compounding. And there is only one compounding period. So however much you can borrow today will grow by a growth factor of 1.09, and today's debt will grow into $3,000. When we solve for the value of PV, we divide both sides by 1.09, and for reasons that will make sense later, I'm going to write this as, rather than divided by 1.09 on the left side, times 1 over 1.09. Mathematically, they're the same thing. 3,000 times 1 over 1.09 is the same as 3,000 divided by 1.09. Okay, they're the same thing. And when you compute, this is $2,752.29 that you can borrow today. So of course, it's a little bit less that you get your hands on than the $3,000 that you'll have to pay back. We can go on to ask, if you can repay $3,000 3 years from now, and the annual interest rate is 9% compounded annually, same as the previous example, how large a loan can you afford to take out now? I encourage you to pause the video here and solve this before unpausing and seeing the solution. The thought process in this problem is exactly the same as in the previous one. The loan you can afford to take out now is the present value in the compound interest formula. So the debt that you are taking on today will eventually grow into $3,000 after being multiplied by 1.09 3 times instead of 1 time, because 3 years are going by before you repay. So we plug the known values into the compound interest formula and solve. Fv is known to be 3,000. I is the same 0.09 that it was before. So the 1 year growth factor is 1.09 still, just as in the previous example. But now n, the number of compoundings, is 3. When we solve by dividing both sides by 1.09 to the third, notice how I'm writing this. Again, 3,000 times 1 over something. 1 over 1.09 to the third. That's keeping track, when I write it this way, of how many years of compounding took place. When we go and compute this, it turns out that $2,316.55 is the amount that you can borrow today based on your repayment 3 years from now. Notice that that's actually a little bit less than you're able to borrow based on repayment 1 year from now. If it takes you longer to make the same sized repayment of $3,000 in the future, that works against you, and that shows up in the fact that you were able to borrow less money in the present. And now the moment of truth. This is what we're really after. Consider multiple regular repayments. If you can repay $3,000 at the end of every year from 2016 through 2018, what is the total amount that you can afford to borrow at the beginning of 2016? So at the beginning of 2016, January 1st, you want to borrow some significant amount of money, and the way you're going to pay it off is $3,000 at the end of 2016, another $3,000 at the end of 2017, and another $3,000 at the end of 2018. A helpful way of thinking about this is to imagine that you're taking out 3 different loans, and to help keep those separate from one another in your head, imagine that they're each from a different bank. Each loan is going to be repaid with a single $3,000 payment a certain number of years in the future, but a different number of years for each bank. Thus, you're taking out 3 separate loans at the beginning of 2016. you're repaying the bank number 1 loan with a certain $3,000 at the end of 2016, you're repaying the bank number 2 loan with a different $3,000 at the end of 2017, and then you're repaying the bank number 3 loan with yet another $3,000 at the end of 2018. Thus, the total amount that you can borrow at the beginning of 2016 equals the amount that you can borrow from bank number 1, based on repaying $3,000 at the end of 2016, plus how much you can borrow from bank number 2, based on repaying $3,000 at the end of 2017, plus the amount that you'll be able to borrow from bank number 3, based on repaying them $3,000 at the end of 2018. These are 3 separate loans, and each one has its own computation of how much each bank will lend you at the beginning of 2016, based on your promised repayment. But we've already done this computation for banks 1 and 3, and we can see the thought process for bank number 2 as well. For bank number 1, we figured out that you could borrow $3,000 times 1 over 1.09. For bank number 3, we figured out that you'll be able to borrow $3,000 times 1 over 1.09 cubed. By the same sort of thinking, the amount that you can borrow from bank number 2 will be $3,000 times 1 over 1.09 squared. The sum of these is what you'll be able to borrow at the beginning of 2016. Thus, our total loan amount equals the sum of these 3 expressions, and when we go and compute how much they equal and sum it all up, it turns out to be $7,593.88. The most important thing to understand is that the answer to this question of how much you can borrow is equal to the value of this sum. This sum is the present value of an annuity, since the large sum of money changes hands first, and then the smaller regular payments of $3,000 each come afterwards. Before going on to the next video, answer the following question. If you can repay $3,000 at the end of every year from 2016 through 2019, what is the total amount you can afford to borrow at the beginning of 2016? In other words, this question is just asking about making 4 years of $3,000 payments instead of just 3 years, as we just computed. So try to use what we just worked out in the previous example and extend the thinking to one more payment.